welcome back to a new YouTube video. Today we're going over a new skill. This is Scatterplots. Of course, when we go around new skills, we're starting with the foundational difficulty level. If you have any questions about this, make sure to leave it in the comments. Make sure to subscribe if you haven't already. And let's get started with this first question. So this is talking about college enrollment. We have our little scatterplot and also a line of best fit to represent that data on our screen. The scatter plot shows the data of the percentage P of 18 to 24-year-olds enrolled in degree-granting institutions over the past several decades, where T stands for years since 1965. A line of best fit is shown on the graph. What is the P-intercept, or Y-intercept really, of the model tells us about the enrollment of 18 to 24-year-olds in degree-granting institutions. So our Y-intercept is where X is 0, or the year since 1965 is 0, meaning it is 1965 in that year, and that was about 22%. So in 1965, 22% of students were enrolled. So that means answer choice A is correct. On to our next question here. Once again, we have a scatter plot, line of best fit. The scatter plot plots the relationship between hours spent on video games and hours spent on homework last week for students in Joyce's class. Joyce created the following scattering plot and trend line to show this relationship. Assuming the line correctly shows a trend in the data, what does it mean that line's y-intercept is 23? So this just means in general, when people spend 0 hours on video games, they're going to spend about 23 hours on homework. And of course, Joyce isn't a point here, so that means answer choice A and answer choice B are going to be incorrect. But the graph indicates that people who spend 0 hours on video games, that's our x-axis point, will average approximately, because of that line of best fit, it's an approximate estimate, 23 hours spent on homework. Answer choice D is correct. A ranger in Kruger National Park collected data about the elephant population. She compared the foot lengths of elephants and their shoulder height and created a scatter plot and trend line. Assuming the line correctly models the trend in the data, what does this line slope of 5.89 mean? That means rise over run. So that means we rise 5.89, or shoulder height increases by 5.89 centimeters every time the foot length increases by 1 centimeter. So it's that rate of change. Foot length increase of 1 centimeter means 5.8 centimeter increase in shoulder height. Of course, because it's 1 for the x-axis and then that value, or 5.89 for the y-axis. If x-axis is foot length, it's going to be that 1 centimeter increase for foot length, 5.89 for shoulder height. Last question here. Jude sees a scatter plot relating altitude and temperature in his meteorology textbook. Given that X stands for altitudes in thousands of feet, Y stands for temperature, which of the following is the best interpretation of the slope of the line of best fit? So all we have to do here is find the slope of this line of best fit. Pretty simple. We can see it's decreasing. This point's at about 59. This point is about 1,55. So that's about a decrease of 4 when we go over 1. So it's minus 4 degrees Fahrenheit when we go up 1,000 feet. So minus 4 degrees for 1,000 feet, or decreases by about 3.5 or 4 for every 1,000 feet of elevation gain. That is very approximate to what we found in our slope. And obviously that makes sense. As we increase in height, you may notice about all those mountains, Mount Everest, and also in the plane. When you're higher in the air, it's going to be lower in temperature. So this makes sense right here. C is correct. That was all for this foundational difficulty level of scatter plots. Of course, if you have any remaining questions, just let me know. I'll do my best to answer them in the comments, and I'll see you guys when we go over the medium and difficulty of this skill. Goodbye.